Hey guys, welcome to another video. Today, another video in the final question series that I've been trying to put together. Today's question comes from the advanced syllabus. It's the final question in the North Sydney Boys 2024 trial paper. Now, it's a nice one. It's actually quite hard. It feels, for those that actually know, it feels a little extension two, but it's in advance, right? The theory that we need to know is in advance. The techniques that we need to know in advance. So a really nice question, quite challenging, right? And sometimes I might be doing something and you're like, how do I know to do that? Well, practice, experience, right? So now, before I dive in, as always, if you haven't already done so and you like these videos, subscribe to the channel, tell your friends, and then once you're done with this video, like the video itself, guys. Let's dive right in. So, North Sydney Boys, 5 marks to conclude their trial paper. Right, so let's see what we got here. So show, okay, I use green. Show this, okay. Show that, okay, it's just show, right? Not anything too fancy about that. But what's important here is hint. There's a hint here, right? It goes, show that the function is increasing. Okay, that's interesting. And then lastly, show this inequality. Look, the question itself isn't that hard, right? In terms to understand, it's just show two things, but the techniques on how to do this is quite tricky. Let's have a go. So, part one. Now, zoom in so I can write a little bit neater. All right, first part, because show that I want to show this guy, right, is greater than 1. Oh no, greater than 1 plus x. Okay, 1 plus x. Okay. And then it goes, show that that's increased. Now, interestingly, right, if I minus the 1 plus x over to the other side, I get this function, right? Yeah, so they've minused it over. So what they really want me to show in this part here is, if I can show that fx is greater than 0 or greater than equal to 0, I'm done, right? Because then if fx, this is basically saying that ex minus 1 plus x is greater than equal to 0. And then I move the 1 plus x over and I actually prove what I want to do, right? That's what they're trying to make me do. So how do I do that? It's asking me to prove this increasing point. Now, I'm going to draw a diagram to illustrate the concept. So this is actually in 4 unit as well, right? In the proofs, calculus proofs topic. So if I had any graph, right? Let's say, for example, any function, right? If I had to prove that the function was always positive, I need to do 2 parts. There's 2 parts to my proof. If I can prove that the starting point is positive, right? So show that the starting point is over here somewhere, right? So point number 1. Yeah. Show that f of 0, so when x equals 0 is greater than or equal to 0, right? So show that it's 0 or positive, right? Step 1, right? So maybe I'll call it number 1. Yeah. And then number 2, if you can show that the function from that point on always increases, right? Yeah. So number 2, show fx is increasing, then this function is always going to be positive. It never comes back down, right? If I start positive and continue upwards, I'm never going to be negative. That's the concept. Yeah. That's what we're going to try and do. So step 1, step 2, show that. Now, how do you show something is increasing? You show that f dash x is greater than 0. That's important, right? So that's what we're going to try to do. Yeah, that's what we're going to try and do. So let's see, part 1, right? Part 1. If I sub f of 0 in to the function itself, it'll be e0 minus 1 plus 0, which is 1 minus 1, which is 0, and that's greater than or equal to 0. Perfect. Right? Oh, sorry, that's greater than or equal. That is 0. Right? It equals 0. Therefore, f of 0 equals 0. Yeah, and what's my range? I'm subbing in 0 because it tells me that the lowest value is 0. Okay, so it doesn't even want me to look at negative numbers. It just wants from this point. From this point onwards, right? It just wants this far. Now, what did I just prove? I proved that my starting point is actually on the origin. That's good. Still good. I just now need to prove that it increases from that point onwards, right? So point 1's done. Point 2. Now I need to find a derivative, right, for 2. Right, so if I differentiated that function, I'll get ex minus 1. Now we know that ex is always greater than, so for x equals 0, it equals to 1, right? Yeah, so when x is greater than equals 0, ex is greater than equal to 1, right? Yeah, so therefore, f dash x is always going to be greater than equal to 0 when x is greater than equal to 0. Does that make sense, right? Because when x is greater than 0, the ex function is, when x equals 0, it's 1, and then it increases thereafter. It has to be greater than equal to 1, right? Yeah, so once I got that, guys, I've just proven that the starting point is 0, and then from that point onwards, it's always either 0, so it's either flat, right, or increasing, which is fine, right? So therefore, I can conclude, given these two elements, right, therefore, fx is greater than equal to 0, right, when x is greater than equal to 0. In this case, right, fx was ex minus 1 plus x greater than equal to 0. Therefore, ax is greater than equal to 1 plus x when x is greater than equal to 0. And that's what I want. Yeah. So prove the starting point is greater than equal to 0, right? Because that's your starting point. And thereafter, if you can prove that it's increasing or equal to 0, brilliant, right? That's put those two aspects together to prove that inequality. That's tricky, right? And that is it feels, for those that do 4-unit, that feels like a 4-unit quality. Actually, that is part of the content in 4-unit. In 2-unit, it's less so, but conceptually, it makes sense, right? Conceptually, it makes sense. Now, part 2, prove this triple sort of inequality, right? There's 3 parts to this, right? Now, if I was to isolate, so let me just write the question here. So show, okay, show four and 3 less than or equal to integral 0 to 1 ax squared dx less than or equal to, was it? E. Now, you in advance cannot integrate this guy, right? That is not part of the syllabus, right? Yeah, 4-unit, you probably can do that by parts, but in 2-unit, you can't. So the whole purpose of this is not to integrate that bit, yeah? Now, first thing I'm going to show you is whenever you do questions like, the harder questions especially, and they do part 1, you have to use it, right? You have to basically use part 1 somehow to do part 2. Now, what did we, from 1, what did I prove? I proved that ex is basically greater than or equal to 1 plus x. Now let's rearrange that. So 1 plus x is less than or equal to ex. Now in this question here, it feels like I'm going to put a squared there, right? So if I replace x with squared, I get that inequality. Now, I'm just going to explore that a bit. If that's the case, it looks like I'm taking integrals of both sides. If I integrate both sides, right? I think this actually gives me, if I go limit from 0 to 1, 0 to 1, right? I think I actually get it, because let's see. Integrating that, I get x plus x cubed on 3, 1, 0, less than that same integral. And guys, if I sub 1 in, I get 4 and 3, right? So therefore, 4 on 3 less than or equal to the integral of 0, 1 dx squared dx. I've got all the dx's. Oops. Hey guys, I've proven half my requirement, right? The question requires me to prove that. I've proven the first 2, right? Because it wants me to prove A is less than B less than C. I've just proven A less than B. Perfect. Now I'll go to the half, and then I'm done. Yeah, is that okay? So that's half the story gone. Good. Now, also, go this right. And right now, on the other side, what's to go here? Ax squared. I've got A. Now, let's see if this makes sense, right? So 4 Now, because the limit's only between 0 and 1, right? So 4x between 0 and 1. Yeah, we know that. You know that. X squared is less than or equal to x, right? So on the graph, if you think about it, right? Yeah, between 0 and 1, y equals to x looks like this. Yeah, but the parabola is below it, right? Yeah, this guy here is y equals to x. Yeah, that's y equals. That's y equals to x. This guy here is y equals to x squared, right? It's always below it. So that's true, fact. Yeah. No. If that's the case, if I exponential both sides, because exponential graphs are increasing, the inequality doesn't change, right? Yeah, and you have to write here, since y equals to e fx is, well, actually, e x is increasing function. Yeah, that's important. Yeah, then you get that. And then I integrate both sides. I see where it takes me, right? So then if I integrate it with 0 to 1, ex squared dx, because it's increasing, it doesn't change the inequality there. Yeah, I'll leave this side here. I know this side here equals to ex 0. That equals to e minus 1, e minus 1. Is that right? Yeah. Now, therefore, right, this guy, ex squared dx is less than or equal to e minus 1. Now, if it's less than e minus 1, right, if you think about it, on a number line, right, I've got 0 over here. I've got e over here, right, which is like 2.7 something. E minus 1 is over here, right? Right now, I've proven that the inequality is less than this. So then it must be less than e, right? Yeah. So that's how I'm going to conclude it, right? I'm going to go, this guy's less than this guy, which is less than or equal to e. Also, not less than or equal to, it is less than, right? Less than e. Yeah. I've proven that part. And when I combine these two, I've gotten what I have, right? Yeah. So therefore, yeah. Therefore, 4 and 3. So let me just have a quick look at the question again, make sure I proved it. Yep, perfect. Therefore, 4 and 3, put them together now, less than or equal to 1 ex squared dx less than or equal to e. Right, when I combine all three elements A, B, C together, right? So, in this question, it's quite nice. Prove it from using part 1, you prove A is less than B. Yeah, and then comparing x squared and x, you prove B is less than C, splice them together, and you get the final proof. Guys, nice question. Final question, 5 marks, North Sydney boys, advanced paper for 2024. Hopefully you like that, right? If you do, please like the video, subscribe to the channel, and tell your friends. Thank you very much. I'll see you in the next one.